Hi roboticist! Today we are going to be talking about how to simplify a URDF file using xacro file and macro. Before diving into it, make sure to subscribe to the channel and give a thumbs up if you like this video and if you want more topics on learning ROS and a lot of techniques that will be very useful. In the last video, we have learned how to model a robot with a URDF file, and we have built a 6-axis robot using links and joints. In particular, our robot is modeled using cylinders of different dimension in length, and one cylinder is linked together with revolute joint. We have created a launch file for visualizing the robot with RVs, that stands for ROS visualization, and we have activated the joint state publisher GUI for playing with the joint to check the behavior of the robots. This node is able to represent each joint via sliders that goes from the lower limits and the upper limits. That is gonna be minus pi and plus pi, or better 3.14 in radians. The scope of this video is to simplify the URDF using xacro file, and in particular we are going to use macro. This will simplify a lot the URDF file, and you will see how to pass from almost 200 lines of code in let's say the half, and you will see how. And this is very useful if we wanted to better make an order of your URDF file, and gives us the possibility to be more readable for external user too. If we look at the URDF file, we can see that the robot has been modeled using 5 links and the base link as well. All links has a shape of a cylinder, and if you see, all these links have the same structure, meaning that we have the visual with the geometry and the origin and the collision as well. So we could consider these variable as parameter of a macro tag that characterize these links that represent a cylinder. The same concept we are going to use for the connector and the gripper, where the links in that case are boxes with different sizes. So we have created our macro for describing the links that subscribe a cylinder and a box that could be differentiated thanks to the parameter. And now we can do the same for the joints as well, where we generalize as parameter the variable like name, type, parent link, child link, and the limit and the origin in XYZ, and roll, pitch, and yaw. Okay, we have set up our xacro file, and we need to use this generalization method of link and joint in our URDF. So now we're gonna modify our URDF, and first of all we need to include the xacro file. And then we're going to substitute step by step each link using a macro to check if we made a mistake and if everything works properly as before. So you're gonna type brackets, xacro, semicolon, and then the name of the macro that you gave, and then we need to assign to each parameter of the macro the value that we want. So we can copy the params part of our xacro macro tag to be sure to not make any mistake. And paste in our URDF file in the xacro tag. And give, for example, the as a name the base link, the origin in XYZ, 0, 0 and 0.025, and so we just copy and paste the same values that we set before. So the radius for the base link is gonna be 0.1, and the length is gonna be 0.05, and this is the base link. And you can see that almost around about let's say 10 lines of code is simplified in just 2 lines of code, because we have used macro. So it is very useful to make all this file readable. So save the URDF file, and let's launch the rvs.launch file to check if everything works properly. Okay, it's open, and if we go down, we can see that the base link is in the same position and has the same dimension that we set before, meaning that this method of xacro macro file is working properly. We can check with the joint state publisher GUI if something changed, but it seems that nothing changed, so we have set everything properly. Okay, then we can cancel the link that we have commented out before, and I hope that you have understood the logic. So you can use the same method for all the links and the joints as well. So I'm gonna comment one more to make sure that you have understood. So we are gonna copy the xacro cobot link cylinder, and we are gonna change the values in as a name. We're gonna put link 1, and we are gonna modify the origin in X, Y, Z in Z in 0.132 and radius 0.05 and length 0.264, which are the same value that we set as link 1 in the previous video. Then we can create our macro tag for the cobot joints, and as before, we can copy and paste the parameter that characterize the macro of the cobot joint. So copy and paste as we did before. Okay, and then now we need to assign to each parameter the value that we set before as the base link __ link 1, which is our first joint, Revolut joint. So as name, we're gonna put the same base link 1, then it's gonna be of type Revolut. The parent is gonna be the base link, link 1 as a child link, and so on and so forth. And make sure that you copy the same value that you set before, so you don't go in trouble when you spawn your robot with this method. Okay, let's check if everything works, and in RVs we launch the RVs launch file, and it's working properly. So now we can do the same for all the joints and link as well, because the method is gonna be the same, with the exception, of course, that you need to update the value that we set in the last video. Then we arrived to our TCP or end effector, and we're gonna do the same. So we just need to copy and paste the parameter of the macro cobot link box, but the logic is the same. I'll put the name, TCP connector, the origin in XYZ, the origin in roll, pitch and yaw, and the size of our box. And we can do the same for the links and the gripper right and left. Okay, finally everything is done and we can check if everything works. And so we're gonna launch our RVs, and it seems that everything works properly. The joints, the links, and we didn't miss anything. So you feel free to play with the randomize bottom of your joint state publisher GUI. And as you can see, from almost 200 lines of code, we reached around about 70 lines of code, of course with the usage of the xacro, this xacro macro file where we build our macro. But I hope that you get the point, and you have learned well how to simplify your URDF file in such a way that it could be much more readable also for other users. Okay, that's all for today. Thank you for your attention, and if you like this video, don't forget to subscribe to the channel and give a thumbs up and turn on the bell for get the notification when a new video is popping up. And I'm gonna publish round about 1 or 2 video per week, and I can assure you that you are going to follow a good pathway in learning robotics with ROS. And if you stick with this sequence of video, you will have your learning experience much better, rather than grasp a lot of video without any structure around the web. So I hope that you enjoyed this video and keep learning robotics with ROS.